Hello all, welcome to this lecture where we are going to talk about evaluating model performance. This is a very important concept. So let's start with what is a confusion matrix. So a confusion matrix is a table summarizing the performance of a classification model by showing actual versus predicted results. So typically you will see what are the actual results shown at the top, and then you will see what are the predicted results shown at the left side. Now let's understand more with an example. Let's take an example of binary classification wherein we'll want to check whether an email is a spam or non-spam. So let's first discuss positive cases, which means you predicted something to be positive and it turned out positive. And then we'll discuss negative cases, which means you predicted something to be negative and it turned out negative. So when you predict something to be positive and it is actually positive, then it is true positive. For example, you predict that this particular email is spam and it is actually spam, then that is called true positive case. And similarly, when you predict something to be negative and it turns out negative, it is called true negative, which means in this example, you predicted this to be non-spam and it was actually non-spam. So it is true negative. So both of these have been indicated in green color, which means whatever you predicted turned out to be correct. That's the reason the first keyword is true and then it is positive or negative. So this confusion matrix can actually get very confusing. So try to understand these terms so that you will be able to make sense out of it. So true means your outcome was same as what you predicted. It can be true positive or it can be true negative. Let's look into next examples. Next one is false positive. Over here, you predicted the output to be positive. However, it was negative, which means your prediction was wrong. Similarly, we have false negative. Over here, you predicted something to be negative, but it turns out it was actually positive. So that's why it is called false negative. So when it starts with false, it means your prediction went wrong. Okay. And what was your prediction? Whether it was positive or negative, based on that, it will be either false positive or false negative. Let's discuss this with an example. We already discussed about true positive and true negative cases. And what is false negative? With the example, when the model incorrectly labels a spam email as non-spam. Over here, the outcome we predicted was non-spam, which is a negative outcome. Remember, the model was built to identify spam emails. Okay. So if the outcome is negative, but it turned out to be incorrect, that's why it is false negative or FN. And lastly, false positive. So when the model incorrectly labels a non-spam email as spam. So the model predicted something to be spam, which is a positive outcome, which is what it is expected to do. However, this prediction was incorrect. That's why it is false positive or FP as we call it. Now let's discuss some of the model evaluation methods using this confusion matrix. The first one is accuracy. So accuracy is percentage of correct predictions, which is true positive and true negative. Only the green ones in this slide out of all predictions. So the formula is true positive plus true negative over total predictions. So it is interested only in correct predictions, which are the green ones, out of total predictions. So in this example, out of 100 test emails, true positives were 30 and true negatives were 40. Then accuracy is 70 divided by 100, which is 0.7 or 70%. So this is what accuracy is all about. And the limitation of this evaluation method is it is not ideal for imbalanced dataset. High accuracy can be misleading if one class dominates. For example, you are using this matrix to find out what is the accuracy of fraud prevention. As we know, fraud happens very rarely, maybe one fraud in 1,000 transactions. So if I build a model which tells all transactions as genuine transactions or non-fraud transactions, which means I would be correct 999 times out of 1,000 times. So which gives me accuracy of 99.9%. But we are missing all the fraud transactions in that case, right? So that's where accuracy has limitations. Okay, next one to discuss is precision. So precision measures how accurately the model identifies true positives out of all positive predictions. And its formula is correctly predicted positives divided by all positive predictions. So the formula considers only the first row, which is true positive TP divided by true positive plus false positive. And if we go by the example, here true positive is 30 and false positive is 20. So precision is 30 divided by 30 plus 20, which is 0.6 or 60%. And when do we use precision? When the focus is on minimizing false positive. For instance, avoiding marking legitimate emails as spam. Next one is recall, also known as true positive rate. And why is it used? It is used for measuring the model's ability to correctly identify all true positives in the dataset. And its formula is correctly predicted positive ones divided by all actual positives. So it focuses on the left hand side column wherein it considers true positive and which is divided by true positive plus false negative. And in this example, it is 30 divided by 30 plus 10, which comes out to be 0.75 or 75%. And it is useful when minimizing false negatives is critical. In our example, ensuring spam emails are not missed. Now let's see trade-off between precision and recall and when to use what. So when you want high precision, it means you want fewer or less false positives. And for high recall, it means you want less false negatives. An example over here is avoiding misclassification of legitimate emails, whereas legitimate emails should not be classified as spam. You need high precision. Versus ensuring most spam emails are detected, you need high recall. This is typically a business decision whether they want high precision, which means less false positives, or they want high recall, which means less false negatives. And based on this, the data scientist will build a model keeping a goal of high precision or high recall. Going further, precision and recall often cannot both be optimized simultaneously. So increasing precision may lead to lower recall and vice versa. So you will have to decide what is your focus, whether it is high precision or high recall. Next one is F1 score. F1 score harmonizes precision and recall by calculating their harmonic mean. And its formula is given on the screen. It is 2 times precision and recall divided by precision plus recall. And the use case over here is, it is ideal when both precision and recall are important for model evaluation. An application to spam model discussion. In scenario where both minimizing false positive and capturing true positives are essential. However, as we discussed earlier, trying to increase precision may decrease your recall and vice versa. So this is very, very difficult to achieve a high F1 score. But if you want to consider both precision and recall, and if you want to balance it out, then you may try to evaluate F1 score. Let's quickly check last 2 methods for evaluation. First one is true negative rate or TNR. It is also called as specificity. And its definition is ratio of true negatives out of all negative predictions. So over here in this diagram, it considers the right hand side column, which is the negative ones. So the formula is true negative divided by false positive plus true negative. And in our example, it measures accuracy in correctly identifying non-target instances, example identifying non-spam emails. Let's move to the last one, which is false positive rate or FPR. Again, this considers the right hand side column of negative ones. So the definition is the proportion of false positives out of all negative predictions. So it considers FP divided by FP plus true negative. So in our example, it shows how the model manages non-target predictions. Example, predicting spam for non-spam items. Okay, so that's pretty much in this lecture. Some of these concepts like precision and recall are very important. Please try out these calculations yourself by taking some examples. This will help you understand these concepts better. See you in the next one where we are going to discuss more evaluation methods. Thank you. Bye.